Hi, good morning, everyone. Hope everyone is in good shape and staying safe. I'm Ying, known to my peers as Zawa also. I will be the moderator for today's webinar. Okay. We are glad to have architect Chong Lee Siong with us again today. He will be bringing his message to us. Please exit before taking selfie. It's not after taking selfie, it's before taking selfie. Okay. So we are also broadcasting the seminar live on Pamnc Northern Chapter Facebook page. Feel free to share with your friends. However, for those who are viewing through the Facebook page, there will be no CPT points. For those who have registered with CPD points and are in this Zoom meeting, please be reminded to jot down the sign-in code that is currently displayed, and also the sign-out code at the end of this seminar. I believe many would have known architect Chong Lee Siong by now. He's very active in the study of fire safety engineering from an architectural perspective. He is also a member of the Institute of Fire Engineers and contributed to the drafting of the current Uniform Building Bylaws 2012 version, and also the publication of a Guide to Fire Protection in Malaysia, and has delivered numerous papers on the application and interpretation of fire safety provisions. For the rest of his background, I believe you can easily find from any event website. Next, should you have any questions during the talk, please type them in the chat box and we will answer them during Q&A session later. And I shall not waste any more time. I will pass to our Pamnc Northern Chapter Chairman for his opening remarks. Over to you, Chairman.
Very good morning to everybody. Hope everybody is safe and well in these trying times. On behalf of Pamnc Northern Chapter, I'd like to thank all the attendees attending the webinar, Gary'sPXL.co for hosting the webinar, and architect Chong Kok Jun, and our ever efficient Pamnc Secretariat, Pat and Emily. Thank you, Zawa, for being our moderator and guiding us smoothly through the webinar. Last but not least, of course, thank you, architect Chong Lee Siong, for giving us your time and knowledge to share with us. Okay. I have just 3 points I want to make before architect Chong Lee Siong starts. One, actually, in terms of fire safety, the responsibility of the PSP. Second, eventually, I think the title is actually self-certification. And then the third point is how to minimize your risk from being sued or illegal action being taken against you. Okay, fire safety is an important aspect of building design, obviously, and it's one of the most critical components of fire safety design in the preservation of human life. And this will be, I think, the topic of today's talk by architect Chong Lee Siong. Okay, so point one, PSP ultimate responsibility and the importance of understanding fire safety design. Fire safety inspection is quite common in Malaysia. You know, you submit your application to Bomba and they approve your passive design, and then the M&E consultant comes in and do the active design. And then after that, when you're just about to finish your building, they come and inspect your building and then give you the approval. I think in some countries, they don't do that. What happens is actually the architects and the consultants actually are responsible for the design of fire safety in the building. So ultimately, what happens is actually you do the design for fire safety, and then you submit it to Bomba. Maybe in those cases, they submit to relevant authorities. And those documents are just kept for record. Ultimately, as I said, the PSP is actually responsible. Okay. Well, this is a bit of a double-edged sword. You know, now recently, I'm sure most of you know that Bomba has actually they come and inspect, and within 14 days, they're supposed to actually give you a feedback on the building and the fire safety design. And if they don't, it's considered that you have already passed that aspect in, I think it's G8 and G9 form. I said it's a double-edged sword because then ultimately it goes back to the PSP responsibility if something goes wrong. Okay, so for the future, to sort of reduce the risk, this is the third item. We recommend that all our members actually keep fire safety updated all the time by attending seminars. So one of the good news is I think Architect Chong Lee Siong and the whole team in Pamnc, KL, under the professional practice group is setting up a workshop. I think it's end of the year. Maybe Architect Chong Lee Siong later can actually confirm or otherwise the time frame for this. And I would actually encourage all of you to attend and keep updated all the time, okay? This is one of the way we could kind of learn and keep updated and reduce the risk of being sued by people, okay? Because eventually the self-certification, what will happen is actually they won't even look at your drawings. They'll just keep it for record. If anything goes wrong, they go back to the record. And the person who submit will be responsible. So without further ado, I'll let Architect Chong Lee Siong have the floor. And thank you very much for your attendance. Enjoy the seminar. Thank you.
Thank you, Architect Liao, and thank you, Architect Zawa. It's nice to be back to Penang again, albeit virtually, but I can almost smell the Assam Laksa from here now. I'm getting closer and closer to get back to Penang, and I really love that. Yeah, really, thank you so much again for this opportunity to share with you all. As Architect Liao has started off by saying about self-certification and all that, self-certification, it's really what it has always been. Even though we say that the authorities are the ones who approve our plans, Bombards are the ones who stamp on the plans and all that, but being the principal submitting person, in any case, we are fully liable and fully responsible for all our submissions. There's really no doubt about that. There's no question about that. I do recall when I first came back to Malaysia after studying overseas and practicing overseas. It's 30 years ago. I had a shock of my life the other day when I realized that I've been back in Malaysia for 30 years already. When I first came back in January 1991, I got myself a job in a firm in KL. I did my first submission to Bomba as one of my very first projects, and so I was preparing the plans together with our draftsmen at that time. I was filling in, trying to mark out where the fire hydrants are, where the hose reels are, and my the chief technician of the office then in Malaysia at that time, he came over to me and said, "Why are you doing all that?" I said, "Well, I have to go and consult Bomba. I have to bring these plans and talk to Bomba whether am I complying with the bylaws correctly." Then the draftsman told me, he said, "No, we don't do that like that here." I said, "How do you do that?" He said, "You send a blank plan to Bomba. In a couple of weeks, Bomba will call you and they will return the plans to you with Bomba's markings on where you put hose reels, where you put the fire doors, and where you put all those things." And I had a shock of my life. I said, "What? We actually relying on Bomba to tell us how to design our buildings?" And they said, "That's the way it is." So it was a bit of shock to me. I thought that we are the architects. We are wholly responsible for our design, and we should really be the ones who knows best on what our design should be, and how to design it safely. So, but anyway, of course, things have changed an awful lot in the 30 years now. As we stand today, of course, the Malaysian practice and all that has really gone up to international standards. The world has become so small. Really, the world is one big world now, and we all really working in one common standard, at least in one common understanding, if not in terms of the trade barriers and all that. We are really subscribing to the common good. Yeah, we all know what are the correct things to do, and we are all moving in the same direction already. And of course, Malaysia is no different. Over the last 20 years or so, we have really moved on, and we are now very much in the process of self-certification, because like you see, the CCC and all that, that has only occurred over the last 15 years. Yeah, prior to that, we still have to submit our, well, we get our building plans approved, then we built it, and we have to apply to the authorities for all the various approvals, and it is a local authority that grants us a certificate of fitness. Yeah, but nowadays, nobody even talk about that anymore. CCC is issued by a Borang F from us as the architects. Yeah, so really, we are the custodians of what we do, and all the standards and all the advancement in design, the advancement in safety, the advancement in engineering really comes from the profession itself, and we are the lead. We are the lead profession in the building industry, because the buildings are designed by us architects. Yeah, and I think that's really a very heavy responsibility on our shoulders. So it's all the more reason why we should always uphold our understanding of well, we should always uphold, yeah, this institution of continuous improvement in our design and in our engineering approach to the architectural aesthetics of the building, of course, but also to its functionality, and very importantly, the safety of the buildings. Yeah, so this is where we stand today. Yep. So all the bylaws and all that, I've always said that the uniform building bylaws and all the building codes that we have is not a recipe for good building design. It's not meant to be that. Now, all the codes and the bylaws, they are really just a set of rules, a very minimum filter for the purposes of having our plans going through this approval process, so that the public in general can be assured that at the very minimum, our buildings will comply with the minimum acceptable standards for public safety. That is all. It is definitely not a recipe book for you to create a new building, for you to create a good building or a good architectural design. It is, the recipe is created by us. We are the architects. We are the chief chef of the restaurant. So all the recipes are created by us. Yeah, the bylaws is not a recipe book. So really, yeah, that is the point. So in fact, with the recipes that we create, with all the buildings that we have created, with all the things that we have learned, with all the advancement in technology, we should be the ones who go back to the authority and say, look, our standards have increased tremendously. This shall now be the new standard that should be adopted as the minimum standards for statutory compliance. So we are the custodians of standards, we are the custodians of good design, and we are the custodians of all the advancements in technology. Yeah. So yeah, okay, I'll get right into it. The topic today is an extract from all my previous CPDs, particularly looking at exits, evacuation and exits. It wouldn't be too long because our intention is that we will keep half an hour for towards the end of the seminar at about 11:30. We will want to keep half an hour for an interactive question and answer session that Zawa will be moderating at that time. So okay, let's get down to it. Let me share my slides. All right, please exit before taking a selfie. Okay, the basics of concept fire safety are definitely not changed throughout the years. I'll just recap it from here. Designing for fire safety, the basic concepts is still that 4 fundamental concepts. The most important thing is that we'll always be designing for evacuation. Life safety is the primary objective in fire safety design. So evacuation will be the first line of defense against fire. Evacuation, passive containment, active intervention, and last but not least, access for firefighting and rescue. And we all know from the bylaws, the items 1 to 3, evacuation, passive containment, and active intervention, you will be referring to all the schedules in the Uniform Building Bylaws that prescribes differing prescriptions to commensurate with the different purpose groups. You'll have a different. We have 8 purpose groups in our Uniform Building Bylaws. Buildings are generally classified into 8 purpose groups, and each of the prescriptions for the design for evacuation, passive containment, and active intervention are very specific to the purpose groups, related to the size of and volume of the buildings for the very specific purpose groups. Whereas designing for firefighting and rescue, on the other hand, is referring to the overall size of the building, volume, again, floor areas and volume of the building, and height of the building, without any specific reference to purpose groups. So you'll find that items 1 to 3 involves intrinsically the building itself, components of the building itself, whereas designing for access for firefighting and rescue is very much about the external access and the link to the firefighting shafts and the internal firefighting active systems related to firefighting operations and rescue operations. So that one is not specific to purpose groups, but on the other hand, it's very much related to the size and volume of the building. So with this general understanding, we'll be able to zero in on looking for the specific references in the process of our design. All right, today we'll be talking specifically about evacuation. Detection, of course, evacuation involves the whole gamut of the process of detection, alarm, exits, travel distance, components, capacity of exits, etc., etc. But let's look at. I seem to have a bit of a problem with the mouse. I don't know why the screen is not moving. Okay, never mind. I'm sharing my screen. Can someone just tell me, are you actually seeing the bar here on your screen?
The red font, right? Only one fire at one location.
That's right. Yeah.
Yes,
You're seeing that. Okay.
Yes.
Okay. You're not seeing any of my control bars, is it?
No.
No. Okay, that's good. That's good.
But we can see your arrow.
That's good. That's good. Okay. Okay. Excellent. Because my own control bar is blocking my screen. Okay. No problems. Okay. So the basic concept of designing for evacuation is that in terms of the most minimum accepted risk level that we're designing for, is that we will assume that there will only be one fire occurring at one location at one time. We are not going to design it for any greater risk than that, unless you're designing a very specific building. Let's say, for example, if you're designing the building for the American Embassy, our minimum bylaws, compliance with just our Uniform Building Bylaws will not be suitable for the American embassy, because the American embassy want you to design for other kind of risk. You know, they want you to design to protect the building from terrorists. They want you to design the building to protect from someone driving a car bomb through the front gate. They want you to protect it from a missile falling through the roof. They want you to, they'll have a lot of their own known risks that they want to design against. Whereas for general buildings, buildings for the public, if there are no specific risks that you're designing for, as a general term, our uniform building bylaw just say you design it to meet at least just one minimum risk, and that is there be a fire occurring. There will always be the risk of a fire occurring in one location. It could be any location, anywhere, but just one fire at one time, right? In that one location at one time, right? You can't be that unlucky that you have to design for two fires occurring at opposite sides of the building at one time. Right? So this is a general principle. That's what I mean by minimum standards, right? There's just a minimum gate for a minimum bar for us to design and say, okay, we have complied with the minimum requirements. Right, and on this concept, then it allows us to move on in how we apply all the other references to designing. Right, so the basic concept of designing for fire safety is, again, I'm having some problems with my mouse. My apologies. Okay, I'll just share a quick video with you. This is plucked off YouTube, so I don't own this video at all. It is the setting is that this is a real life video, by the way. I think it's somewhere in China or Hong Kong. It is a very typical single room apartment, and the setting is that you can see this little kid over here. The kid is wide awake, and there's an adult beside the kid playing with his iPhone or whatever, lounging. Could be a nice Sunday morning, and the kid is looking at this electric scooter. Right? The kid is obviously very fascinated with this electric scooter, and this electric scooter is connected to its charger. The battery is being charged. Yeah, and this video is real time. So okay, there's a clock over here on the video recording, so you can just watch the time. This is in real time. So let me just turn on the video, and here we go. Oops, sorry. Ugh. My apologies. Okay. Okay, that was a very short video. From the pop, when the battery first short circuited, to the big blast, it's about 16 seconds. That video is real time. So that's how long it took for the situation to be out of control in that particular room from a lithium-ion battery on an electric scooter. Yeah. The nature of fire is such. This is a chart of a nature of fire. Right, there will always be an ignition. Right, for a fire to start, you need the fuel. Fuel is literally anything with a carbon base or anything that's reactive. And of course, you need heat, and you need the presence of oxygen. That's generally how you start an oxidizing fire. There'll be the ignition. Then once the ignition catches hold, the rest of the fuel will start to be consumed as the heat spreads to the fuel, and the fire will gradually build its way up, and you'll come to a point where the fire would have taken hold, and the temperature in the room or in its immediate environment becomes so hot that the other components or the other contents of the room will also start to combust on its own, because the heat has reached the point where it's reached the combustibility limit of the fuel. So the ignition will start on all the other components as well. Okay, so there will be this time here where the fire really catches hold, and every other contents in the room will start to burn, and the fire will then really burn until everything that can be burned will have already been on fire. Then the fire will then start to decay, right? And that is where the fire will start to smolder off as the combustion, as it runs out of fuel, and the combustion just gradually fades off. This is the point here where we call it as a flashover, and that is the point where the temperature in the room becomes so hot that everything else starts to self-combust. It's a bit like in an oven. You put you set the temperature on the oven to say 250 degrees, and you put a chicken in there. When it reaches 250 degrees, the chicken will start to brown. If you have to put some tomatoes, you have to put some vegetables in there at the same time, those things will also start to burn and brown. Yeah, because it's reached the point where it's reached the ignitability temperature of the content itself, of the fuel itself. So at which point is it between the ignition of the fire to the point where the flashover occurs? At which point in time within this period do you think it will be still safe for the occupants to remain in the room? Right, the occupants will definitely have to run out way before flashover. Obviously, as you've seen from the picture just now, the explosion occurred very early, within 16 seconds. Right, so the untenable condition is actually reached very early in the life of a fire. You don't have to wait for flashover. Really, by the time you reach flashover, there'll be nothing left in the room. So human beings we wouldn't be alive, yeah, to see flashover if we remain in the room. Right. So untenable condition in a given environment when a fire starts is actually occurs very early in the life of a fire. And that is the short period in which we'll be concerning ourselves with this morning with regards to the designing for exits, designing for evacuation. Let me just expand that graph there. So therefore, we have the time of the ignition of the fire to the point of untenable condition. Using the example of the video, let's use that as an example. It was 16 seconds before, it only took 16 seconds. We'll take the pop, that big pop on the explosion, the initial explosion on the battery as the ignition. And in 16 seconds, the whole thing exploded. We saw a big white flash in the entire screen. So let's take this period as 16 seconds. Okay, now that would be what I'll call the available safe egress time, the asset. In that given situation, you've got 16 seconds before untenable condition is reached. So what transpired within that time from 0 to 16 seconds? Let's look at it. There had to be a detection, right? So the kid and the adult was there. The initial detection actually occurred very early, right? We heard the pop. So that was the ignition. So yeah, there will be a slight delay in the reaction time. First, there was the pop. So you can take that as the initial alarm. Pop. Hey, something is wrong, right? But it wouldn't have occurred to the occupants of the house at that time that the pop was a fire. Right? So what did the guy do? He walked towards the bicycle. He walks towards the battery to have a look at it. And when he saw the smoke coming up, okay, that's when detection occurred. So the adult detected the fire. He heard the pop, he heard an early alarm, he saw he detected the fire. And what did he then do? He tried to do something, isn't it? They try to fiddle around with that. Oh, is the battery really burning? Maybe I want to switch off the battery or whatever. Yeah, and then he sort of realized when the smoke started to come out, he sort of realized, oh no, it doesn't work. Yeah, so in any other situation, he would have raised the alarm. In this case, what did he do? He looked at it and said, oh my goodness. So he raised the alarm on himself because there was nobody else in the room other than the kid. Then it came the point where he decided that, whoops, when the smoke started spewing out, he better start to evacuate. So he turned around, he grabbed the kid, and he started moving towards the door, and he ran out of the video screen. He went away, so we couldn't see him anymore. And presumably he's left the room when he left the video screen, presumably, so he's already left the room. Total evacuation. So they managed to leave the room before the end of the 16 seconds. So the time it took from the ignition, going through the whole process and all that, and finally he grabbed the kid and leave the room. That is called the required safe egress time, because he must leave the room before the untenable condition occurs. Right? And as a general rule of thumb, we would want to design the place for a safe evacuation that the required safe egress time, that means this is our design element. This is what we are going to design into our buildings to allow occupants to exit the room within about 3/4 of the time available for them to exit the room. Right, so this time over here will then be the buffer. It will be the safety buffer. Right, this is the basic concept of evacuation. The example I've shown is very, very simple. It is just one small room, one adult, they're wide awake, they're looking at the fire, they heard the pop, alarm, the adult raised it, he determined that he has to exit from the room, it's going to be dangerous, grabbed the kid, he ran out. So it's a very, very simple, very, very basic example, but that is the basic concept of designing for evacuation. So therefore, when we apply it to our buildings, as they get more and more complicated, from one single room apartment, we also apply this all the way to large public buildings and all that. And this is where all these elements come in. To allow all this to happen, right, we can't avoid the ignition of the fire. That is the risk, right? We will do everything to mitigate the risk. But however, should a fire occur, that is the emergency. That is the situation that we have to address. So therefore, we have to be looking at how the detection can occur, how the alarm can be raised, and how do we get people to start moving, and how do we shorten or absolutely minimize the movement time of all the occupants in the building so that we achieve total evacuation within the calculated required safe egress time to allow us to have a factor of safety from the available safe egress time before the conditions can become untenable. And this is where all these are the ingredients then available to us for us to use. The bylaws will only be setting very minimum criteria as to when you will require these installations, but these are all the ingredients, and all these ingredients are meant for us as the architects, of course, together with a full design support from our engineers and all the other experts out there in the field, for us to put together a correct recipe that would be appropriate for the type of building that we're designing, appropriate for the kind of fire risk that we can foresee, for the purposes of safety of the building, safety of the occupants of the building. All right, so for the detection, very, very early detection from the ignition, we have VESTA, the very early smoke detection systems. Smoke and heat detectors, we also have active suppression systems. In much simpler buildings where you don't have active detection systems, like say in your own home, Our own home doesn't. We don't have bylaws to say to require us to install detection systems our own home. It's only very, very recently at the last revision of the bylaws that we introduced smoke detectors into apartment buildings. That is all. Yeah? And we also introduced the requirement that every home should have fire extinguishers. That is really, really the most basic first step in introducing, in raising the standards required for residential buildings. But otherwise, residential buildings, by law, you actually do not need any active firefighting systems or active detection systems. Then when it comes to raising of the alarm, there are pre-alarm systems triggered by the detectors, alarms that are triggered by the active suppression systems. And of course, there are manual alarms to be triggered by people, you and me, occupants of the building. Then for the movement, there will be directions via public address systems, especially in large-scale buildings, multi-tenancy buildings or public buildings, buildings with a lot of members of the public. Directions by the emergency response team for campuses or institutions that is mandated to have emergency response teams, and of course follow the herd lah. When someone screams and yells fire, 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 and then they start to run, everybody else follows, following the herd. And eventually then on the movement, in terms of our passive design to keep people safe, you have to lead them to the final exit or lead them to refuge areas, or would they be still stuck within the building by this time? No, we really, really don't want that. Right? The whole intention is to get everybody out of the building. That's what this line means. Total evacuation. Everybody is out through the final exit or out into a refuge area. If you're designing a very, very complex building, you get them into a refuge area. You don't want people to be still stuck within the building beyond this timeline. So how do we start calculating all of these things? Where do we even start to assess the risk of the building that we design in terms of the fire risk? How big would the fire ever be in the building? How do we even calculate reset? How do we even calculate the asset in the first place? Not let alone then designing the building to the correct reset time. Well, there are, if we are moving in the performance-based engineering approach, as a lot of us would have done, if we're doing extremely large buildings or buildings that just cannot or buildings that are just beyond the scope of the uniform building bylaws, we go for the performance-based approach. And in performance-based approach, of course, we use simulations. Primarily, there will be the simulations of the fire load, the simulation on the propagation of the fire and the smoke, and then, of course, the simulation of the occupants of the building and how they run, how people evacuate, dialing in all this data in terms of the ignition, the load of the fire, how fast will the fire be propagating, the response time of the detection of the active systems that we've installed, the response time of the people themselves responding to the alarm, response time of the emergency response team in getting people to start moving in the right direction, and the capacity of the exit routes and the exit doorways, all the areas of refuge to accommodate the people to get them out of the total evacuation. So everything can be simulated. If you're doing a performance-based approach engineering, that is what we have to do. I'll just share with you a very simple video of some of the engineering tools that we have. Okay, this particular one is a simulation of an actual fire. This fire is on a nightclub in Rhode Island in the US of A. This is a famous incident whereby an infamous incident whereby this nightclub was fully occupied. I think they've got about 200 over people in this nightclub. They're fully occupied. They were watching a stage show. The performers on the stage were using pyrotechnics, and when some of the fireworks went off behind the stage, it caught fire on the ceiling, on the combustible drapes, and the styrofoam stage stage props. It caught fire. This building wasn't sprinkled, and the exits, because it's a nightclub, you see, you have to enter with a ticket. You have to pay to enter, and there are bouncers at all the gates checking on entry and preventing people from just coming in and out. So when the fire occurred, yeah, there was massive panic. Everyone tried to get their way out, and eventually I think it's about 70 over people perished in this fire. So in order to, well, they're doing forensics on this situation. They just want to study what actually happened. And this particular video is one of the simulations of what may have transpired during the fire in this nightclub. Right, by putting in the data, they came up with this simulation. Oops. Somehow my mouse is not responding to this, the slide is not responding to the
You can try click on space
space.
and try click cursor.
Click on space, is it?
Click on space and then try use your cursor again.
Oh, space and oops. Space, oops. Instead of keep jumping to the next screen, it's not responding to the click to play. Okay, never mind. I'll skip this one. You may have seen this. I'm sure most of you have seen the simulation before. Generally, you see all these little dots over here. Each one of them represent a person. So the initial space was filled up with people all over here. Then the clock starts running, and that's where the fire started on the stage over here. And you see all the people trying to go out, and they're all jamming around these are the exits that the bouncers have locked. The bouncers did not allow anyone in, nor did the bouncers allow anyone to get out, even though there's a big raging fire behind there. See, the bouncers are outside, you see, so the bouncers are kind of safe. And this scene that you see here is actually at the end. All these white dots are the people who perished. They are the ones who could not get out of the exit. Right, so the white dots represent the people who perished in this scenario. It's the same scenario as we would, like, say, when we're designing the toll booths, the capacity of the toll booths. We've all experienced this, right? When we're all driving under normal days, our tolls are actually kind of efficient. We just go past it, flash our touch and go or smart tag, and away we go. But during Hari Raya or any of the public holidays, the exits at the toll booths are always always congested. So it's very much the same principle. First, you see how many occupants are there at that given time. How fast do we need to evacuate? What is the desired flow rate? Is it okay for us to wait 15 minutes at the toll booth before we exit the toll booth? Is 30 minutes okay for you? No, I think we'll all be terribly frustrated. We'll be calling the plus hotline all the time. We will say, okay, maybe on the jam, maximum 5 minutes I can tolerate waiting, queuing up at the toll gate before I can exit. Okay, so how fast do we need to evacuate? Then the correlation of this, that means the number of occupants to the desired rate of exit, will then give us the required exit width. How many toll booths do you have to install at that particular exit, right? If that exit, if you know that there's going to be a great number of cars at that exit, you want to install more toll booths. Lesser, then you can install less toll booths. So the concept is exactly the same. So coming back again as to how in the world do we determine all that without going through performance-based simulation, or is it that every time when we design we have to go through all the performance-based simulation? No, see, that's where the uniform building bylaws come in. The uniform building bylaw is the very, very basic filter that someone behind the scenes has really worked out all these simulations and calculations and formulas and all that, and we have come up then with the bare basic set of rules and regulations, minimum compliances. If you just comply to this set of minimum compliances, then your design is deemed to comply. Their absolute minimum is not the full recipe for you to design the building, but however, it is just the very, very barest basic ingredient. If you just have this ingredient appropriately applied to your design, you're deemed to comply. You do not need to prove any more to the authorities. Yeah, all we have to do is satisfy ourselves that, hey, we are actually designing a very, very good building. Yeah, of course we have met all the minimum standards, but I'm also going to improve on this. I'm going to make this even greater, way beyond the minimum standards, because I want to create a beautiful dish. So I'll be improvising on my recipes and all that. Yeah, but however, while we are doing that, we know we have already complied with the most basic gatekeeping. And the uniform bylaws is just that. It's the first gate that you cross. Understand it fully, apply it, you're deemed to comply. Cross that first gate. Then beyond that, it's entirely for us to explore and to improve our design, bring it to the as high as we intend to be. Yeah, we chase our dreams. We are all designers. The joy in our lives is creating buildings. So do not ever allow the bylaws to be the thing that constrain your design. Rather, the understanding of the bylaw is just a basic building block. Once you clear the basic building blocks, everything else is for us to go. The sky is also not the limit anymore. We are space tourists now going to space. So I would say there's no limit to our creativity. There's absolutely no limits to the architect's work. Yeah, we are really, really such a privilege. A lot of professionals as architects. Once you clear these basic compliances, there's nothing to stop us from pursuing our dreams. Whatever it is that you can imagine, there's nothing to stop you. But first, let's just clear the basic compliances, get it out of the way. Yeah, so the people behind the bylaws have already done all those hard work for you. You don't have to go through performance evaluations. You don't have to go through simulations. Just use this one, yeah, the basic requirements. So when it comes to evacuation, there are two basic controls. One is travel distances within the individual buildings. They set a limit to the travel distance. How far can you travel within the building? And the other control is on occupancy load. How do you classify what would be the statutory minimum occupant load for the purpose group that you're designing? It just says that. It doesn't say, now the bylaws does not say that the occupant loads here is the limit. It is not the limit. This is purely for the purposes of having the base standard for us to calculate the capacity of the exits that we have to provide, minimum compliances. For example, when it says office, it puts here occupant load per meter. Meter square per occupant that you have to allocate. So it says 10 square meters. That is not the limit, right? It doesn't mean that you cannot have your office design to accommodate one person every 3 square meters, for example. In a lot of our the office cubicle designs, office cubicle layouts that we do nowadays, you'll find that the typical floor area of the office cubicle is no more than 2 square meters. Then if you plus the circulation and then going around it, on average, every occupant would be occupying no more than 4 square meters. Right? Now, this bylaw does not limit you from doing that. Right? It never says that you cannot load up the building to. It doesn't say that you cannot pack up the people in the form of sardines. A future office may be that everyone only have a standing room, nobody's got a desk, because we are all on our mobile equipment now. We are all wired with headsets and all these things. So all we really need to do is just stand. We don't need a table. We don't need a workstation, right? It doesn't limit you on that. The bylaw does not limit you on that. What it does is that it says that if you're designing a speculative office space for an office, the minimum compliance is this. You design it for the minimum compliance. But if we as architects want to design for a higher occupant load, then we must be aware that we have to design it for the purposes of higher occupant load. That is all it says. Yeah? That's how we apply the bylaws. The principle is very simple. If we look at the way in which the purpose groups are classified, and the way all the different schedules related to occupant load and related to the travel distances and related to how we calculate the width of the exits is actually all related to the occupants of the building and the kind of risk factor associated with the kind of activity within that purpose group. Right? For example, in an office, the occupants in the office, if they're working in an office, so presumably they'll be very, very familiar with the office, right? They go to work every day and they go home from work every day. They know exactly where the pantries are. They obviously know where they park their cars. They know where all the staircases are. They know every day they walk past a fire extinguisher. They know exactly what it is. And if you're working in a corporate tower, they'll have their regular fire drills and all that. So the workers in the office will be very, very familiar with the environment. Most of them even have the key to the front door, so they will know exactly where the front doors are. And the occupants of the office, by virtue of it being an office, that means it's occupied during working hours, all the occupants should be pretty much able-bodied and wide awake, right? You don't go to the office to sleep. You go to the office to work, so you have to be pretty much alert and wide awake. So that is the risk element in the office. The occupants are wide awake. They are able to run immediately. They know exactly where everything is, very familiar. On the other extreme end, you have the hospitals with the inpatient wards, with the ICUs, with the patients, inpatients. Yeah, they're the occupants of the hospital, the inpatients, are in the extreme polar opposite from the occupants of the office. They will be on the bed. A lot of them are sedated. They are intubated. They are totally not mobile on their own. They will require full assistance. They're not even aware of the surroundings because a lot of them are not even awake. They are sleeping. They are sedated. Some of them may even, unfortunately, be in a coma. So they totally require other people to assist them in an emergency situation. They're totally dependent in that time that they're in the hospital. So therefore, this puts them in the greatest risk. So therefore, the bylaw is written in such a way that when it comes to travel distance and all that, it's all correlated to the degree of risk posed by the occupants. For example, in office, in the current bylaws now, the maximum travel distance is 75 meters. And the exit capacity per exit module can accommodate 60 persons. Right? So just as an analogy, if you're designing that particular office compartment to house 60 persons, you can have an office with maximum travel distances of 75 meters. And because you're housing the office with 60 occupants, you need a minimum of only one exit module, because one exit module, 550 millimeters, will accommodate 60 persons, will accommodate the evacuation of 60 persons. Right? Now, in contrast to say hospital inpatient, travel distance in an ICU or an inpatient hospital is actually limited to 35 meters. Right? Because you really wouldn't want to have to push the inpatients longer than the distance of 35 meters, because it just takes too long. Exposure to the fire is just way too risky, way too long. And the exit capacity is only 15 persons per exit module. So if you're designing this hospital inpatient, that compartment that we are designing is say 60 persons here and 60 persons over there. For the office, the minimum requirement is only one exit module. Whereas in the hospital, your space is less than half of the horizontal distance of the office, and you need 4 times the exits width as that of the office, because the exit capacity is limited to only 15 persons per module. So to cater for 60 inpatient occupants, you need 4 times the exit module, 4 times the exit width as that required by the office. That is how the bylaw works. Very simple. Everything is all tabulated, and all we need to do is just pick the right, apply the appropriate prescriptions, and you'll find that you've already crossed the first barrier. Then the sky's the limit to our design creativity. Right? Nothing else will stop us as architects. If you work it the other way around, we start with the bylaws first and use all these constraints and then you design inwards, I think we'll definitely be limiting our creativity. Rather, it's the other way around. Get this as the basic foundation blocks. Get that one in, then whew, great designs are ours to create. Yeah. So having said that, now let's look at some of the psychological things that will assist us in our design, particularly for evacuation. We are still talking about evacuation here. So it's human nature that when we are faced with adversity, do we stand, get our club ready and fight, or do we flight? Do we run? When faced with adversity, do we face it or do we run? In the case of a fire, most times we would want to run. Yeah, but of course, if it's a small fire and all that, yeah, we might want to fight it. That's what extinguishers are for. That's why we are equipped with fire extinguishers. That's why we are equipped with, buildings are equipped with hose reels, because fire extinguishers and hose reels are meant for the use of the building occupants. Bomba will not bother using that. By the time they count, the fire will be so full grown anyway. The extinguishers and the extinguishers and the hose reels will be of no use. You can't put out the fire. So extinguishers and hose reels are first aid only. That's meant for us to fight. But if you can't control it, like the guy in the video, there's no way he can control the explosion of the battery. So you flight, you run. So designing for evacuation means that we are just catering for these guys over here. Give them a path to run. Why do we find that insects always fly towards the light, right? When we even have those insect killers, the one with the ultraviolet light. Yeah, because Why do bugs fly into the light? What is this natural phenomenon that bugs fly into the light? Actually, human beings do exactly the same thing too, you know. Because when in flight, in this particular case, we're talking about when in flight from an indoor fire, you know, come back to the context of designing for fire evacuation, we will always choose to retrace the route from which we enter the building. Right? You walk into the building. If it's a building that you're very, very familiar with, the path from the entrance to your office cubicle that you work will be the most traveled path. You will literally be able to walk that path blindfolded, right? Because you just do it every day. The exact same number of steps, the exact same turning. Yeah, you're most familiar with the way in. Even if it's the first time you're entering a new premise, the first time you're visiting a mega shopping complex, the entrance would be your first landmark. When you enter the building, you will say, "Oh, I've entered from this building." Then, as you walk along, you would remember, "Oh, I'm passing this shop. I'm turning around that corner. Oh, the McDonald's is just behind that one." So the first path that you've seen will be the ones that's most familiar to you. And should there be an emergency, or should you actually get lost, you know, don't even talk about an emergency. You say, "Oh no, you know, I sort of, I don't know where I am now." What is the instinctive thing that we want to do? We want to trace back the path. We go back to the same path that we came in. Yeah? So in the event of an emergency, the most natural reaction when people say you better get out of the building, you have to evacuate, the most instinctive thing every one of us would do would be we would be retracing the route from which we enter the building. We go back in the opposite direction from whence we entered the building. Then we will always prefer brightness over darkness. This is always yin and yang. Just as the same reason why insects always fly into the light instead of flying into the darkness, human beings, we do exactly the same thing. Given in a dark tunnel, where would you want to go? You would look for the light at the end of the tunnel, right? We will always instinctively prefer brightness over darkness. And definitely, we will always prefer open air over enclosed areas. Why? Because open air gives us fresh air, gives us sunshine, it gives us the wind, it gives us comfort. Enclosed areas are always like, they close you in, it's claustrophobic. Especially in the event of emergency, the enclosed areas is the exact area that we're trying to get ourselves out of, right? Faced with a doorway, if you're moving in one direction, if one door is open, another door is closed, we would definitely not bother trying to open the closed door, right? If one door is open, we go through the open door. That's natural. And we always want to be able to see. The reason why we prefer an open doorway over a closed doorway is simply because we can see right through the open doorway. We know what's on the other side. So if the door is closed and the door got a view panel or a glass or it's a transparent door, we will instinctively want to go towards the see-through door over a solid door. Yeah, and last but not least, is the light at the end of the tunnel, because ultimately in an adverse situation, we always look for the light at the end of the tunnel. It's an English idiom, right? It applies to everything. We always look for the light at the end of the tunnel. That is actually very, very appropriate, literally, in what we are doing over here. When we're designing for evacuation, we are designing to give the light at the end of the tunnel for the occupants of the building to run towards to. This picture was taken when I was, this picture is many years old. I think it's more than 20 over years old. It was one of my early commissions. I was doing I was doing a fire audit on this hotel, which was decommissioned at that time. The new owners are coming in, so we're doing an audit of the building. It's a due diligence audit for the new owners. The power was off. There was no power in this building. Even the emergency lights are not on. Why? Because the genset, everything is totally shut off. So we're walking in the when we're doing an audit, we entered the typical hotel floor. It was absolutely pitch black. And we said, "How are we going to do the audit? We don't even have have light in there, you know, and we can't. There's no daylight because this is the hotel corridor. All the hotel rooms are also closed. So this picture was taken with a flashlight of the camera. Now, 20 years ago, we don't have smartphones. We don't have we don't have camera phones. No smartphones. So we're using our own. I don't even know if it's a digital camera at that time. So this picture was taken by the flash of the camera. I was just pointing in an absolute total pitch blackness, and I flashed the camera, and this is what we saw. There was absolutely nothing at the end, right? Total blackness. So it's not something that in an event of emergency you will actually want to walk towards, right? Because we don't know what we're going to see there. This is a bit more palatable, right? If you are in this situation in the event of an emergency, all these doors are of a similar transparency. You can see through it. You see through that door, and it's a blank wall. Right? You see through these doors, you see that they are empty shop lots. But of course, there's a keluar sign there, so you'll say, yeah lah, that has to be the way out. Yeah. So it's about it's about clarity in terms of where the exits are. If you take away the keluar sign, I don't know. Then there may be some doubts as to, okay, is there a way out of here, or is this a dead end? Now, this would definitely be less vague. We can see daylight coming through there. So even if we can't see the keluar sign, there is actually a keluar sign over there. Even if we don't see the keluar sign, which is actually quite inconspicuous anyway, we will find that in the event of emergency, we will not be trying to break through any of these doors, right? Oh, can this door open? Is there an exit behind these doors? I don't think we will do that. We see broad daylight coming over there, we'll all be running towards there. And if we run towards there, we find that the door is locked, what do? We will try and break down the door. Why? Because we can actually see outdoors, we see the light. So instinctively, we would be running towards the light at the end of the tunnel. Indoor corridors like this, there are so much signages, there's so much things to distract us. We can't see outside, but of course, everything is nice and brightly lit. Beautiful environment, very nice. I suppose we would then have to rely quite a fair bit on signages. Signages that are distinctive for people, signages that does not blend into all these directional signages. I think it would be quite ridiculous if, say, an exit sign is over here and said, oh, the arrow is exit. You have to run through, figure out everything before you decide where the exit is. I don't think it works. Emergency exit, like in this case, I think it's very well done. Everything has got a very beautiful muted tone, and the emergency exits has got a distinctive green livery, which is standing out from this immediate environment. Right? There'll be no hesitation and no ambiguity as to where the exit paths are in this situation. We are again, we need a lot of assurances. These exit signs are mandatory. These are the statutory exit signs. You have to install these signs. And these signs are, of course, governed by the Malaysian standards in our case. The exact shape and font and size are all governed. And these are minimum standards. See, that's my surprising thing. See, Malaysian standards specifies the minimum dimensions and the minimum configuration of how these signs are. Malaysian standards actually does not limit the size of our exit signs. What it says is that it's minimum, and then the font must not be with the serif. It must not be a serif font. It has to be a block letter font without serif, so that it's obviously clear, a bit like our car license plates. But our car license plates are designed with the exact dimension. That means you cannot be bigger, you cannot be smaller, right? That is our car license plates. But keluar sign, the standards are actually just minimum. You must use block letters, and it's that minimum dimension. It doesn't say that it cannot be bigger. But however, everyone takes the standard as minimum, and all statutory signs are this size. Okay, so that's perfectly okay. That's perfectly okay. That's the minimum. So you put a sign there to comply. So in this situation, you have a very reflective glass door. This is actually inside. Behind this glass door is outside. That is the driveway, the car porch. Yeah. So, but because the glass is so reflective and the lighting on the inside is so bright, you don't actually see too much of the exterior. What you see is your own reflection when you're running towards it. And this is not a push bar door. It is an auto sliding door. So it doesn't exactly look like a conventional emergency exit, but because this is also the front entrance, naturally people would be gravitating themselves towards this. So that minimum compliance with the statutory signage gives that assurance or gives that confirmation that yes, you can exit through here. There are no push bars and all that. You would sort of expect then all these auto sliding mechanisms are already wired and triggered into the alarms, that they would be fail safe, right? When it's fail safe, they will open. Yeah, the fail safe function will be that they will slide open for you in the event of the emergency, right? So if you haven't got if our bylaws does not dictate that you must have keluar signs on the exits, so the sign is off, then this becomes very ambiguous. The occupants of the building may not necessarily know or trust that, was this the same door that I came in? Can I actually exit this door? Would this door slide open for me in the event of an emergency? Yeah. So that's why minimum standards is applied in this situation. As contrast to this example, I think we all know where this is, right? This is KLIA 2. As in contrast to this example, you see they also have the minimum signages up there. These are the statutory signage, exactly the same size and font. Yeah, but in this context, is there any ambiguity as to where the exits are? Would there ever be any ambiguity if you do not install these statutory signages? Would you actually have to tell people where the exits are? I don't think so, because here it says exit, right? And it's so clear. These are all clear glass. You can see right through it outside there. So there's no ambiguity in this. Then you say, Allah, you say the Malaysian standard so ridiculous one. You say you put all these signs so stupid. It spoils the beautiful signage that I've designed we have designed for this grand entrance. So beautiful. Look at this signage. You've got the exact font and all these things, and then the Uniform Building Bylaw spoil our design by requiring these keluar signs stuck at the bottom over here. Yeah, but no, that's how standards work. Because standards just have to ensure that you have the minimum. Because if you don't have the standards in a situation like this, nobody will know where the exits are, right? But then if we are the architects, there's nothing to stop you from really, really, really designing it and to make it very clear to people. Because the minimum standards in this case may not necessarily work. KLIA is such a huge building. These signs are invisible in the building, right? But yeah, it's the minimum compliance, so you still comply with the minimum, but the functionality of the building, the requirements of our design dictates that we will actually have to tell people this is a pintu keluar nombor 2, right? And that one serves the purpose. That's how our standards work. We just have to comply with the bare minimum, but everything else is for us to improve, for us to design it to the point where it far exceeds the requirements of the standards of the bylaws. In situations like this is not Malaysia, this is in Europe somewhere, a very, very fancy restaurant. This is not an exit door per se, because it's not going through a compartment, it's not doing anything, but it is a functional, it is an accommodation door, they're dividing this little lobby here from the slightly higher class dining area over here. The final exit is actually the door behind here, right at the end. That's where the street is. So therefore, our Malaysian standards will also require that you put an exit sign over here. That means this door itself is not actually an exit door. It doesn't comply with an exit door because this is a sliding door. It's got no push bars and all that. But hey, it's an internal accommodation door, right? So you should just make it such that people should be able to use this path, because you have to direct people to the exit behind here. The exit is not visible from where we are. So this is the directional signage to tell you, just go through this door because exit is behind. Yeah, these are what we have to do. In situation like this, now this is again not in Malaysia. A bright, very, very bright glass corridor over here. It leads, which is actually the exit door. Right? You look at the sign of this signage here. This is not Malaysia, but to commensurate with the configuration and the architecture of this doorway, the brightness, and also the length of this corridor. Right? See how big is this sign? Now in Malaysia, I don't think anyone actually makes a sign like this. We can of course we can make it like nothing to stop us from making it. But if you buy a SIRIM approved keluar sign, I don't think we have one of this shape and size, right? Because our SIRIM keluar sign is that little one that we've always been seeing, the keluar sign. So if you put one keluar sign over here, yeah, people would be coming to here because this is nice and bright and it's really outdoors, so people will crash their way through here, whether you tell them it's a keluar or not. But this is what as architects we can do, right? To help to reinforce the directions of the exit, appropriate directions of the exit. And again, in a similar situation, we have the light at the end of the tunnel is here, and we have an exit sign over here, but that's not exactly true, because if you run through here, you'll find that you'll be in the dead end, see, because the actual exit in this particular location, the actual exit is here. Right, so you will require directional signages to point people in the right direction. If this is not prominent, or if this is not prominent, you may get a situation where people will be wasting precious time, getting trapped in dead-end corridors, only for them to have to retrace that route to be able to find the correct exit. And a door like this is also kind of foreboding. If you don't have these exit signs, if you don't have these fire exits, really, you wouldn't know what is behind this door. Kind of foreboding. Back to our country. Well, this one is local, this one is overseas, but also this is a configuration that we see very, very often. Going into a protected lobby before you go to the actual story exit into the stair. So yes, give people assurance that this is the correct way to an exit. This is not the exit in itself, but this is the way, this is the correct door for you to get into to the actual exit, to the actual story exit. Yeah, and again, the same situation over here. We got a fire door here, which is the wholesale cabinet. Actually, the wholesale cabinet is here. I don't know why the door needs to be so tall, but for some reason, the door is very, very big and tall. But the actual exit is over here. So yeah, the signages all works. But most importantly is that in both these examples, you'll find that there are vision panels, and also this one. As what we've said earlier, we would prefer an open doorway to a closed door. If a door is open, we will walk through the door rather than attempting to open a closed door. And secondly, we would always want to be able to see. It gives us more comfort if you can see through the door. If the doors are meant to be closed, if they're fire doors, they're always meant to be closed anyway. But to be able to see through the door, you give us a keluar sign over here, you give us a vision panel, we will all be very, very happy because we'll be able to see through the door. Yes, there is space behind this. Yeah, we can actually walk through this door. And there's no fire behind the door. Right? There isn't, yeah, the space is safe. It's safe for us to walk through. I can see exactly what's behind the door. In this situation, actually, I'm not too sure what this situation was. This is also a very, very old picture from my archives in one of our very, very early building audits. Now, see, there's the keluar sign over here. This one is the proper certified Malaysian standard keluar sign, and so is that. Yeah, this one is the one with the direction, and this one is the one without the direction. Right, but for some reason, someone had the building owners have to add this non MS compliant sign over here. Now, in all these commercial buildings, if you see the kind of maintenance on this building, you would know that this building owner is or this building management is not the kind of management that will spend even one single ringgit to put something that they're not forced to do, right? They don't even spend any money for the maintenance and cleanliness of the building, let alone spending a few ringgit to put up another sign, right? They will not do that. They will only do it because somewhere along the line, either Bomba or the authorities are not say, hey, you idiot, you better put up that sign. And I would think it is because this keluar sign, no doubt, is actually a Malaysian standard compliant keluar sign. The arrow is near invisible because of the size of the arrow. And this is a big departmental store. When this big departmental store is open, the shutters are definitely up, and this is a free walking right through into the store. So if you have a keluar sign over there with the arrow so inconspicuous, in an emergency, the people will be walking right through into the departmental store instead of exiting from here. I believe this is the reason why someone had to spend a few extra ringgit to hang up this sign, because that one got a bigger arrow to tell people that the keluar is actually in this direction and not going through the departmental store. I think that's the situation. In the same building, that very same building that was in the earlier slide, there was this situation. You can see that there are two fire doors over here. One is double leaf, one is a leaf and a half. And none of them got any ironmongery. They all just got these slabs and claps for the dead balls. That one's got the keluar sign. That one had a keluar sign. It's very, very obvious. They had a keluar sign. What was this situation? Well, when we investigated, this door here actually leads to the genset room. The AHU room. So this is not an exit. This is the one that leads to the corridor, to the toilets, and eventually to the story exits. This was actually designed. Someone actually designed the building in this manner. And somebody actually at that time installed a keluar sign into an air handling unit room. And this being the exit, you can see that it's not going to work as an exit anyway. Yeah, there's no proper ironmongery. It's got all this dead box top and bottom, and it's a leaf and a half, with an inactive leaf. Yeah, these are things that are actually designed, not even complying with the bare minimum standards. It doesn't comply. Well, I suppose you can't do any worse than this. Right? If you have to spend money on signages, at least buy the correct signs and put it up correctly. I'm not really sure at all. This is not Malaysia. I pinched this from YouTube. I pinched this from a Google search. If you have to do something, if you have to spend money, at least spend the money correctly and install things correctly. This is a very typical signage that we find in tunnels, in our smart tunnel, in a lot of the European tunnels and all that. And these are actually the proper directional signs as opposed to this one, right? You'll find that in a long tunnel, you can only move left or right. Yeah, you can only move forward or backwards. There are no alternatives. So signages like this appear at regular intervals to tell you where your exits are. Right? It will tell you which is the nearer exit. If the fire risk of its smoke is coming from this direction, then naturally you will know I can't get to the nearest exit. But I know the exit in the opposite direction is how many meters away. Right? Just give people the assurance. If there's no fire, you actually do not see where the smoke is coming from. Then by looking at this signage, you'll know, okay, the nearest exit is really that one. I better run towards it. Unless I see the smoke coming, then I know I can retrace my steps and the other exit is only that distance away. This is our smart tunnel, KL smart tunnel, the upper deck. And yeah, these signs are available at very, very regular intervals. I think these signs are placed at every 100 meters, if I'm not mistaken. Yeah, so at any given opportunity, you will always be able to at least see some of these signs, and you will know which direction, where your nearest exits are, and at least which direction it is. That at least you know what to expect. Again, pictures that I pinched from Google search. I'm not really too sure what is this situation. I just thought it's kind of fun, where if you imagine this door is actually closed, they're all going into exactly the same space. Behind here is actually exactly the same space. I don't know what's behind here. It is just a nice, interesting picture, but it say one door says stage door, the other door says fire exit, and they're all entering in exactly the same space behind this room. So kind of funny. This is definitely Malaysia. This is in I won't say the location. This is actually a multi-purpose, one of those conference halls in a government building. It's Keluar, and this one actually leads to the service corridor, the banquet service corridor, where all the when you're having a banquet in this hall, that's where all that's where the banquet procession comes out from. Yeah, it's a corridor leading. It's a back of house corridor leading to the story exits. But it says no entry over here. Got a single push bar. So um, again, something that I pinched from Google Image. It's an exit. But where's the door? We can't walk through a cabinet, can we? Yeah, or where is the door? Well, actually, the actual situation is this. This is I got this from the website of a company that sells wall stickers, laser printed wall stickers. So someone got the idea that it's a good idea to decorate an exit door to make it look like a cabinet. Is it okay? The exit door. This is obviously an exit door in a long corridor in a hospital, right? Because you can see that there's all these the the trolley skirtings along over here. So this is actually the corridor in the hospital. So this is obviously a path of exit, and this is obviously an exit door because it's got the push bars and all that. And most importantly, it's got all the view panels, so you can actually see right through the corridor, and it gives you the assurance that yes, this is the corridor that will eventually lead you to an exit. Yeah? So I do not know if it's actually a good idea for you to hide the door behind. If it weren't for that sign, you would never ever know that this is an exit door. Even with the sign there, you'll hesitate. You say, "Where in the world is the exit? Where is it? Where am I supposed to go?" In industrial buildings, exits are extremely important because in industrial buildings there are just so many installations, the machinery, the warehouse rackings, and all the other paraphernalia in the manufacturing space. So exit doors are very, very important. It does have to be made kind of prominent, and most times you will find instinctively you will know where the exits are. Why? Because you're actually working there. You're actually trained to work in that particular environment, so you have to go through the safety briefings and the fire drills and all that, so everyone knows. And this one then boils back to the maintenance of the exit provisions. Good proper maintenance to ensure that everything is exactly the way you've designed it for maximum efficiency. In very, very large environments, large warehouses, there'll be a shortage of areas in which you can actually hang a sign or to put up a sign to direct people to exits and all that. So therefore, floor markings are extremely important. Of course, the primary reason for the floor marking is to ensure safety when you're working on a factory floor. There are areas that are meant for the movement of forklifts, autonomous delivery vehicles, which is very, very common nowadays in the country. And it's just a clear demarcation where the people can safely walk. But very often, all these paths are also the safety exit pathway. So markings on the floor is very, very efficient, and it's in a way it's by default that you have to do markings on the floor in large warehouse areas, large environment areas where there are tall ceilings or tall roof. And this one will then lead us to all of these markings, and they're all very, very efficient. Yeah, these are the industrial applications where mostly we use stickers and epoxy markings will do the job very, very well. One item that I don't find to be very common in Malaysia, but it's actually very, very common overseas, are regulatory exit signs that are mounted on the floor or at low levels. Right, like this is a regulatory exit sign somewhere in China. It's actually illuminated and it's mounted at the floor level, right? Because in situation like this, like say in Malaysia, again, I personally have not, well, I've not specified any of this in Malaysia. I have to say I haven't done that, and I don't see this installation in any of the Malaysian hotels that I've been to. There may be some, but I've not seen it. Why? Because our bylaws doesn't ask for it anyway. Right? It doesn't specifically request for it. But this is definitely very common in China and in many, many countries in Europe. This is something that's really very common. I think it's really mandated. It's already included in the bylaws that that you do have to mount low-level exit signs and has to be illuminated. Why? Because in a protected corridor like this, should a fire break out in the hotel room and the fire door is not closed properly when the guy exits, this corridor would be filled with sorry, what happened? This corridor would be filled with smoke very, very quickly. Right? And then you'll find that you would require, when the smoke comes down, people are supposed to then go onto the ground. You're supposed to crawl on the ground so that your head will not be in the smoke. And then you will have to rely on the low-level exit signages to lead you to the exits for obvious reasons. That brings us back to public areas. In public areas, especially in like shopping malls and all that, uh, for for its functionality, of course, all advertising signages, the signs of the shops, all the marketing paraphernalia would of course be fighting for attention. The last thing you want would be, as designers, the last thing we want would be for the exit signage to be the one that is bigger than the Just Go signage. We don't want that. But however, it's so important that for the crowds, for the crowds in your building, for them to actually know where the exits are in the case of an emergency, right? So if you see this signage over here, it's a very, very big arrow. It points to one direction. Of course, people will want to look for where the toilets are and all that. But where exactly is an exit in an environment like this? There's so much signages everywhere. Nobody will even bother to know where the exits are. And in a crowd situation like this, should an alarm occurs, should the evacuation notice comes over the public address system, what happens? Right? You'll find that most instances, we'll just follow the crowd. In an office environment, if there's an emergency response team, there will be a team leader. Say, okay, guys, follow me. I'm the safety guy, so everyone follows him. But in an environment like in the shopping complex, you think the security guards may be trained for the emergency response team, but you think they're up to the job. You know, they have 5 security guards for, say, like 3,000 people in the shopping mall. I don't think they'll be up for the job. In cases like that, herd mentality will happen, right? Somebody, the most panicky person, the person who makes the most noise, and the person who panics the most, and the person who runs in one direction the most, everybody else will follow that person. So if that particular person is actually rushing to the toilet, you can imagine everybody will be following the same person running to the toilet. So uh, designing for emergency signages in environments like that is something that we can definitely improve on. Yeah, and I'm not saying that the bylaws will be restricting us. On the contrary, you'll find that if you just follow basic bylaw signages, like in the examples I've shown you before, in some instances, the minimum compliance doesn't work. The signs are too small. It doesn't work, right? So what we will need is some creativity. We are architects. Creativity is the essence of our lives. Yeah, and this example is from this sign maker. It's an European sign maker, and this is part of the advertising campaign, right? They are the ones who deliver these signs. They make these signs, and they make all these statutory signs. So as part of the marketing campaign, if you buy one of these signs, they will also give you this sign. This is not a statutory sign. This is from the company itself. This is actually the advertising sign. All right. So the company, when you buy something, they will give you this as well, because it will be advertising the company. You'll be complying with the statutory requirement, and by putting it together, you actually improve the signs. Yeah, so because this is how they arranged it. So it's a very, very good gimmick, and I find that it's actually very effective. It's very subtle, and it actually works, and it's lots of fun. I think a sign like this is so much fun. If you take this as a statutory sign, of course the authorities will look at the bylaw and say, hey, double A, because the font had to be exactly like this and all that. But I thought this is so much fun. And that leads me to this favorite example of mine. This one is the metro subway in Stockholm. This particular metro station is built underground. It's an underground metro station. They carved it out of an underground cavern. Underground cavern is like an underground cave. When they first broke through it, they found that it's actually an underground cave. It's an underground cavern. So you can see all of these stalactites or stalagmites and all that, whatever you call them, coming from above. Yeah, and they just didn't have a heart to turn this into an underground station that cuts off all these things. So the existing cave roof of the cavern became part of the structure of this underground metro station. And look at how beautiful the exits are. Yeah, it's absolutely beautiful. And again, see, they do have the statutory signs. The statutory signs are there, but the architects have taken the full opportunity to turn this whole thing. They celebrated the exits while they're celebrating the absolute uniqueness of the underground station. They also celebrated the exits, and it makes these statutory signages so redundant. But heck, what the hell? It's all part of the fun, right? You would never ever ask. You would never ever need to ask anybody, "Hey, where's the emergency exit, please?" Because it's so obvious. Yeah, so it's very beautiful. So therefore, that is definitely a lot better than our Malaysian final exits, right? Right. This is a photograph taken in one of our shopping malls. A final exit. The Keluar sign is there, but okay lah. We get daylight here, so you can't say this one does not function as a final exit. So with that, I will say, yeah, please do design our buildings. Please do not allow the bylaws to constrain. Never ever allow the bylaws to constrain our creativity. Rather, use the bylaws as the basic building blocks we from where we create and from where we expand and explore, and definitely drive our own designs to greater heights. And please do exit the building. In the case of a fire, do exit the building before you take a photograph of yourself and post it on social media, because time is of essence. You got 16 seconds to run out of the building. With that, I'll say thank you very much. I'll hand it back to you, Zawa. Thank you.
Thank you, Lee Siong. Very elaborative sharing on the exit signages. Yeah, regarding this, your title about exit before taking selfie, we do have some friends jokingly say, hey, we should actually take photo of evidence where the fire started. So, all right. For the Q&A session, we hope that we allow for people to raise hands, and then when we call your name, you can just unmute yourself and directly raise the questions rather than typing and listening to both me and Lee Siong only. Okay. Any questions from the floor? If not, I will ask one of it that I have been discussing with some friends. It's on the exit, but more on the ironmongery. Like bylaw 173 did say that all exit doors should be openable from the inside without use of key or special knowledge or effort. But when this happened, there are some clients who actually said, oh, then the escape stairs, we just need to have the like a crash bar or a lever from the inside, but we don't need any lever from the outside, from the staircase side, right? Because this is pretty prescriptive, right? So you are saying that, but then I recall watching all those firefighting dramas or movies, it's like when sometimes the firefighters, in some cases where they need to go back down to go to other floors, to go to the other staircases to fight fire or do any rescues, then when there's no re-entry device, right, then there would be an issue, right? But how do we really determine where we need to install any re-entry device?
Yeah, it's generally accepted now. It's an accepted principle in international fire codes, and also let me put it this way: we have to look at our nearest neighbor in Singapore. Their recent updating of their SCDF codes actually does elaborate on this. It has been practiced in Singapore for a long time also. Why? Because the minimum codes actually is silent on that. If that exit is meant to be exit only for security reasons, no reason for people to enter the staircase and then you go back to another floor that you're not supposed to go to lah. And and especially like in public areas like in shopping malls and all that, the shopping mall owners don't want people to hide in the staircases. Because when they shut down the stores, people enter the staircase, they hide in there. Then when the store is shut, they come out from the staircase and then start ransacking the place. So that has always been a very, very a very, very fundamental security issue, which they think it is. But it has been internationally accepted now that exit staircases, all these high-rise staircases, should be accessible both ways. Because, say, in the Malaysian code, we talked about fire appliance access having access to an access opening, but we never elaborate further on that. And we say the access openings are for firemen to be able to enter the building to reach the firefighting shafts and to be able to reach the other parts of the floor. So the exit routes, i.e. your protected staircases, are actually meant for firemen to enter your building. So if we only have one-way lock sets on all the floors, that defeats that purpose of the access opening. Right? So the bylaw has not been elaborated to that extent because, as I mentioned, the bylaw is just a law. Right? What it doesn't say doesn't necessarily mean that you don't have to do lah. So it is agreed and accepted that all these protected stairs and all that must have access both ways. And if there is a security concern and all that, you have to use electronic systems, ways to be able to control it electronically, and all of this wired to the central command center. Buildings of this complexity is almost definitely require a central command center already. Right? So from there, you'll have to wire all of these systems in. And now with the complication of zone evacuations, phase evacuations and all that, when you're designing to this level of complexity, all these things will come in. So that's why I said the basic bylaw is just the basic building block. Everything else we do, we better do it appropriately.
Thank you, Lee Siong. I think this one is more for like a residential. It's not so complex, but as usual, residential buildings or maybe service apartments, the client always want to save cost.
Yeah, definitely.
But suppose that's how we try to convince and explain to the client the necessity of this.
That is correct. Most important is that your basic specification at the point of us signing off the CCC, let us as architects guard our own standards now, that even if it's not particularly mandated in the bylaws, if we know that it should be done, we better just do it. Never ever fall back to saying that, I'll have to let Bomba approve. Let's see if I can get a waiver from Bomba, or let's see if Bomba asks for it. If Bomba asks for it, then you have to do. If Bomba don't ask for it, we can count in Bomba. Then you're lucky. Don't do. No. Please do not take that approach. Right? Like I said, we are the custodian of the standards of our building. If we know it has to do, we say, I am the architect. I say we need it. Say, but Bomba don't need it. Say the other building also Bomba let it pass. Well, the other building, if you do it like the other building, you'll be facing a lawsuit pretty soon. Okay, so I'm telling you now, you believe me, you spend this money on this lock sets, you won't face a lawsuit. Okay, so as architects, that's what we do. We are the custodian of the built environment. So let us be the ones to dictate what is the appropriate standards that we should deliver to the general public.
Thank you. Very good piece of advice. Architect Liao would like to ask some questions. Maybe you can unmute yourself now.
I think just one question, Architect Chong Lee Siong. Nowadays, actually, we design buildings which are more and more inclusive, right? So are there any provision in terms of, like, let's say, a person with disability goes to the fire escape door, and that person is audibly, visually impaired, and possibly physically impaired, and they are very independent. So you have a latch to the door that that person needs to open. But if he or she is physically impaired and doesn't have the hands and or arms to open, are there any provision now or perhaps in the future to take that into consideration?
Yes,
Because
there is.
because,
Yeah,
mm,
yeah, definitely. We have to start from the UBBL. See, our UBBL does not have all those provisions written down, but we have those provisions when it comes to universal design or design for universal access. Malaysian Standards 1184 is the primary standard, the primary reference code. So the UBBL, I can't remember that particular clause, but that's a clause that we already amended specifically in for the UBBL, the 20121, the one that Penang has just adopted. That particular clause just mentions one thing, that you are to design for the exit of, no, sorry, the principle of the clause is that whatever access you design for the accessibility of people into your building, you must design the same degree for the same occupants that you have allowed into your building to evacuate the building. So that one then refers to MS 1184. And 1184 dictates all the access criteria for people to enter your building. So therefore, you have to reverse all of that to create the evacuation for these people. And primarily of course, for low-rise buildings, we don't have too much of a trouble, because obviously if you're designing for the access for the people into the building, the same route shall be the one you're designing for the exit of the same people out of the building. For high-rise buildings, primarily the access to the upper floors are via the lifts. So that is where then the same clause also refers to evacuation lifts or means of evacuation for people holding the holding areas for the physically impaired people on the exit stairs and on evacuation lifts. Yeah, so that one then you refer to MS 1183. MS 1183 will have a specific section governing the design and the location of evacuation lifts.
it sounds like Siong, that is kind of mandatory anyway. If you
It
get
is.
people in, you've got to get people out. I
It
mean,
is,
you know,
yes.
whichever.
Yes, it is.
Okay.
That's correct.
Okay. Thank
Yes.
you. Thank you.
And anyway, that is also the direction in which we are going now. Not like I said, previously people were taking the Uniform Building Bylaw like a recipe book. Everything we say in the bylaw we do, everything not in the bylaw we don't do lah, you know. But that's not the case now, you see, because we are all referring to standards now. You know? So that's why, like the reference that we're just talking about, the bylaw doesn't give you all the prescriptions anymore. Why? Because the bylaw is just a law. The bylaw just says you do what is right. Oh, what is the right thing we have to do? Then it's referred to the standards. So that's where the standards are empowered via the bylaws.
Because obviously the MS 1184, I think in Penang, or Northern Region rather, we have actually made it mandatory already. I think June this year, I think. So that would have to be incorporated into this fire safety
That is
design.
correct. Yeah. So the evacuation part must be incorporated already.
Yeah.
And read it in conjunction with 1183 on the technicalities of the compliances.
Okay, thank you.
Any more questions from the participants?
Can I ask a question?
Yeah, sure.
Can an enclosed steel staircase be used as a means of escape? A steel staircase, you know, I've seen people screening the steps, and then also cladding with signboard the site and the soffit. But would it be okay to use it as a means of evacuation, steel staircase?
The basic bylaw in the construction section is that they say all staircases used as an exit stair must be constructed out of concrete or have a fire rating, because they're labeled as part of an element of structure. Of course, our bylaw is a legacy from the old British colonial days, and also a legacy from the original bylaw gazetted in 1984. We are definitely doing a lot of steel staircases now, especially the external staircases and all that. I think the principle of this is that you have to fire rate elements that's part of the exit route, part of the exit provisions that are potentially going to be exposed to fire. If you're in a protected shaft and your staircase is made of steel, unprotected steel, and if it's not in any way attached to the building structure, or is it in any way forming any thermal bridges that will allow the heat from the fire to be able to bridge across into this steel structure, rendering it hot, or in a worst case scenario, even melting the entire structure, then yes, I would say you should be able to use a steel staircase. So the principle is not that the staircase has to be fire rated now. The principle is that is the staircase appropriately separated, isolated from the effects of a fire. Yeah, that would be the way I look at it now. And yes, we have actually done a lot of these steel staircases.
Okay, thank you.
Okay, we'll call for another question. Maybe anyone else? Adeline?
Do I need to turn on the video?
It's up to you.
Yeah, okay. Okay, I do have a question because as Zawa, you mentioned regarding on the log set. Okay, I recall.
Adeline, I think there's some issues with your mic, is it? Adeline? I think perhaps the internet connection.
We can't hear Adeline. We lost her.
Yeah. While waiting for Adeline to be back, maybe I'll ask another one. Just now you mentioned something about the occupancy load, like for instance for the office, if we are basing on the 7 schedule, then but in actual fact, sometimes the client, maybe when we are designing at the initial stage and preparing for submission, we may be using the bylaw UBBR, but there's a situation where at a later stage the clients may just squeeze in a lot more table or workstations, then it will significantly increase the occupancy load, right? So should we perhaps just design to what we know may happen in the future, or maybe declare the occupancy load that we did for this design?
Yes, most definitely. If you're designing a built for purpose building, that means you know who the eventual occupant of the building is, designing fit for purpose, then yes, we should design that from the day one. If we know that, especially if you're also the interior designers, you're doing the office layout and order for them. So we should have all those numbers in place and say, yeah, okay, no, you're packing people like sardines in here. Nothing wrong with that. That's your decision. But the numbers are like this, so therefore we have to increase this exit width, and we have to make all these provisions to accommodate that number of people appropriately, lah. For example, now we've done some jobs ourselves, right? Where we put a cafeteria inside an office building. So the stairs are all calculated based on the occupant load. And then when you put the cafeteria, okay, we say, okay, now we got the cafeteria in here. What would be the eventual design capacity of this cafeteria? Now then we have to recheck and increase the size of the stairs appropriately, right, to cater for this. The suggestion is this, again, if you're designing a speculative building, then you might want to actually advise the client or inform the client, or in the building manual that you hand over to the client at the end of this, when you finish the CCC and all that, you want to hand over a building manual to the client, you actually write it down. This this area over here, we got these stairs here, we got these stairs here and all that, and the absolute limit, occupant limit that we've designed for is what is the number. So we tell the client, then it's for them to adhere to it in the future. And it's also good for reference in the future when they renovate the office and all that, and then they submit Bomba plans. Bomba will probably ask the same question. Hey, what was the original capacity that was designed for?
Thank you, Lisa. Okay, I think Adeline's question, she said she recalled the building that she visited. When she entered the staircase, she's only able to access the final exit and not other floors. Is there any requirement on lock set selection?
Yeah, I think we mentioned this earlier, that the bylaw actually does not go down to the level of detail. All it talks about exits. If you're exiting one direction, your lock set must be appropriate in that direction. It doesn't go down to the level of detail, but as I mentioned, that it is an international accepted principle now that these protected stairs will also form possibly the access openings for the fire brigade, for Bomba. So we should design it appropriately, and it's my own personal principle also that I will never ever specify doors into protected stairs that are one way.
Okay, thank you, Lee Siong. Any more questions, as it is already 12? If there's no further questions, then we will end here. Before we end, we would like to thank Lee Siong again for squeezing his precious time and sharing with us all this information. I also like to thank our secretariat who worked very hard to arrange for all this. Architect Kok Chong arranging for this seminar, and also Gary's Excel Pro for helping with all these technology stuffs. Okay, without further ado, thank you everyone. Thank you for your participation. And also please remember to jot down the sign out code later. It's displayed now.
Thank you everyone.
Thank you
everyone.
It's always been a pleasure. Thank you.
Thank you, everybody. Thank you very much. Thank you. Stay safe.
Stay safe.